Again, those methods sort of depend on where you want to take this.
Mm-hmm. So I guess the first thing to discuss is what happens if you get identical things in our particular solution and our null space solution.
Then you need some sort of linearly independent solution.
Okay, so
So you're gonna have to have linear independence, right?
yep,
So you don't want to you want to make sure that whatever you do, you need to make the solutions linearly independent.
yep. So x of n, our null space solution, and x of p, our particular solution, must also be linearly independent from each other. So if we end up getting the exact same stuff, let's say e to the 2t like we had in the last one, in both parts, then we're going to have to find some way to make it linearly independent. Now, we did do that last class with Stuckey, very briefly, but we talked about it. We got a couple, or like we got one example down. So we'll discuss more about that when we come across it. All right, so for the one that we have here, we said that we had our null space solution from earlier. So let me just copy that through. Bring that over here. Okay. So let me also knock this out and give it the larger x sub n null space solution mark. Okay. So now we said that we need to have additionally a particular solution whose derivative is still going to be you'd think I remember it at this point. Oh no, it's over there. Okay. It's on my second monitor. -1, -4, 1, -1, multiplied by our x particular, plus e to the -2t, -2 e to the t. Okay. So, Zach, what is your favorite, perhaps easiest method to come up with solutions, particular solutions for this system?
Okay, so we've got our. I just want to check what the solutions are. So we have our null solution is e to the minus t. It's a combination of sine and cosine.
Yep.
And then e to the minus t, 2 cosine. Hold on. Those are linearly independent. I had to check. Okay. So, and then when you've got this, so I'm looking at this and seeing, well, there's an e to the minus t term. Now I have an e to the minus 2t term, and I have an e to the t term. Those are going to be linearly independent. And I can check the Wronskian on these, right? Like you can
Absolutely.
You can double check. You can double check a Wronskian. But you should be fine because I'm looking at these and not seeing an e to the minus t. I'm not worried about any collision, if you will.
Mm-hmm. And I guess if we wanted to get really technical about it, the e to the -t is also coupled with the sine and cosine portions.
Correct. Yeah.
So,
and that's, again, I'm not worried about it. Like
yeah.
there's not really anything to be concerned about. If we had an e to the minus t sine t somewhere in here, then I'd be a little more worried. Or sine 2t. Even a sine t would be okay because we have some difference.
Some constant multiple of it.
Right. It's not strictly a constant multiple of the original. So.
Okay. So we think, anyway, x sub p should have an e to the -2t and an e to the t in it. And one would hope that that is going to be it for our particular solution. That we just have an e to the negative 2t and an e to the t portion at some point. Do you want to say anything about that?
I just said a thing and it was on mute. I just realized
it
I was
might.
on mute. I said, yeah, I mean, that was my bad. But I will.
Sorry.
No, I don't have anything to add. It's just we're gonna have an e to the minus 2t and an e to the t in it. That's all. And
Right.
probably, I would imagine you're going to have a your first component and said eigenvector, or the vector here, c1 vector rather, is going to have a one in the first component versus the second component. Right, if we're going to solve for, or c1, c2, however you like to think of this.
Right, so it looks like we should have, at the very least, we could say, all right, well, we're going to have a vector multiplied by each of these things in order to make sure that we just have vectors in the first place. Because otherwise, we're not going to get the, well, we're going to have a 1-by-1 matrix, and that's not cool. So our A and our B, we can just say, look, these are going to be constant matrices. If you want to break it down and say that this is going to be, you know, A1, A2, e to the negative 2t plus b1, b2, e to the t. That's also an option. It makes it a little bit easier to see. And if we're going to assume that this is our particular solution here, then what's the next step?
We need to find out what the A1, A2, B1, B2 are.
All right, how do we do it?
So let's see here. You want to so I guess we could write this as a matrix, because I mean, this really, that helps me a little bit.
Yep.
To put this together. So you'd have an A1 e to the minus 2t, B1 e to the t summed, and so on. That's just personal preference. I tend to write those together.
You put them all together.
I put them all together. So I write it as a
Yep.
2-vector, but, like, you know what I mean?
Yep.
But I see, what you're saying is fine. I just want to recognize that, and for those that are viewing this for the first time, it might be useful to see this as a vector in 2 space.
That's
That these are notationally equivalent.
Okay. Now what?
Well, if that's your XP, well, we're going to need to know XP prime.
Because?
The left-hand side.
Right. So we're going all the way back to the system itself. Oh, whoops. That was not supposed to be prime. Sorry, not that one. The one up top. Yeah, so XP prime is going to be equal to our transformation matrix times X sub P. So plug in X sub P into the appropriate locations, and then we also have our G of T vector, the e to the negative 2t, and negative 2 e to the t, all the way at the end. So just plug everything in, and if you want, you can leave it off at first. Just get everything copied down first. All right, prime is equal to -1, -4, 1, -1, multiplied by the same vector. I just literally said same vector. That makes it way easier. We just copy it. Woohoo! Digital age. Work smarter, not harder. Alright, e to the negative 2t and negative 2 e to the t. There. Okay. What do we get for the derivative of the left-hand side?
All right, let's do this. So minus 2a1 e to the negative 2t, and then plus b1 e to the t, and then similarly below. You'll basically copy it.
Yep.
But with the change the b1 and a1 to b2, a2.
Right. All right, is going to be equal to slightly different this time. So now what do we get?
I don't know. As Danny would say, oh barnacles. Okay, so basically, we're gonna take. Let's see. So I'm gonna write this as minus a1 minus 4a2, all in parentheses, times e to the minus 2t. And then the
I
same
think that's
thing.
perfectly fair.
And I'm organizing this a bit in my head differently.
Well, essentially, Zach, what are you doing?
I'm doing the matrix multiplication, but I'm combining the parts that are a1, that are e to the minus 2t and then e to the t terms.
How else would you have done that?
Done that.
Yes.
Very messily by literally writing out all 4 terms that
goodness, no.
here.
Don't do that.
So that's what I'm saying. You could do that, and that's I don't know exactly where you want me to go with that.
That's okay.
But I was sort of mentally like, let's group these together, and I'm just doing matrix multiplication.
So if you had left it as this, with the a1 e to the negative 2t plus, or a1 a2 e to the negative 2t plus b1 b2 e to the t, right? If you had left it as the separated added 2 vectors and then done matrix multiplication, yeah, you're just doing distribution. It's the same left distribution we were talking about before. It doesn't matter how you're organizing it, right? But at the same time, that would allow you to just jump a step and say, I'm not going to worry about doing the negative a1, negative b1, then negative 4a2 and negative 4b2. So it makes it a bit easier just to say, organizing it even just in your head. We're taking just the a terms and doing matrix multiplication on them, doing just the b terms and doing matrix multiplication on them, and then still adding them all together at the end. So it just makes it a little bit easier to work with. Did you catch, non sequitur, did you catch Dr. Gold's last week?
I was there a few times.
Were you there for the Bessie quote?
No.
So he came out with this book, Mathematica. I'm not going to get it off. It's fine.
Okay.
And he had a huge Twitter thread that was all about, we're teaching math wrong. And he's been trying to work this out for the last, 10, 15 years or something like that. And he said essentially the currency that we're playing with in mathematics is not axioms to then further build more and more premises and everything else like that. The currency with which we are playing mathematics, doing the math itself, is neuroplasticity. And I thought that was a very interesting take. Dr. Gold was like, oh my god, I need to go buy that book.
Yeah, I think I vaguely remember something like this. I know that this person's not the first to speak of neuroplasticity. Carol Dweck and so on are some other. It's another I think of. But yes, there's a book by Joe Bowler about mindset and so on. So that kind of stuff has been written about before. But I've never heard of this book. I'll have to take a look at it. You can send me
possibly distilled in slightly a different way.
Sure, yeah. Well, and that's much of what we do, right? A lot of what we do is distilling things in different ways. And then, sorry, so the other ones are just going to be A1 minus A2. Thank you for saving me trouble.
If I really wanted to save you trouble, I would have done it a long time ago.
I was going to say, you really could have. And then you just add on.
Got the G vector in the end, yep.
So now with this one, you could you can add the constants appropriately. You could have the B1 minus B2 minus 2 now, and then a negative A1 minus 4A2 plus 1, right? So we can actually write this as one big conglomeration.
Yep.
Because vector addition is a thing, and vectors are very nice structures to do math in. Which, if anybody's here and is going to be a part of... When I have Real Analysis 3, like it's originally was supposed to be a trilogy, but when this happens in 2025, it's a when, not if. It's just a matter of... but one of the things is going to be... The theme really is that vectors are cool and have some cool properties that make math very, very convenient. So that's like one of the big themes.
All right.
And then we can just sort of solve component-wise.
See, just like we did before when we were talking about partial fraction decomposition. Again, same deal, just like we were talking about up above. With the null space solution dropping out, it's because these two things are equal to each other that we can set them equal to each other in their own special equation and then worry about other stuff in its own special equation. So in this particular case, again, yeah, 100%. We're just going to take our stuff that has e to the negative 2t and deal with it, and stuff that has e to the t and deal with it. Because there's no possible way for you to get a constant multiplied by e to the t to come up with e to the negative 2t. It's just not going to happen. So, alright, this is negative a1 minus 4a2 plus 1 e to the negative 2t plus parentheses negative b1 minus 4a2. Okay, and a1 minus a2 e to the negative 2t plus b1 minus b2 minus 2 e to the t. Lovely. Okay, so at this point, again, we're going to create our own system of equations in order to break down all of our different components. So we get 2a1 has to be equal to, on the other side, negative a1 minus 4a2 plus 1. Yeah. Set it up as vectors. Because, as you say, vectors are cool. Negative 2a2 is going to be a1 minus a2. Okay, and then here we just have no, not over. Goodness. a1, a2.
I do the same thing. The struggle is real there. I can't tell you how many times I've done.
Yep. We're going to just multiply everything by negative a half and clear out the constant. So I'll just stick the negative a half out front for now.
I mean, it may be wise to actually to combine stuff. I'm regretting that. I think you'll regret that choice. Because honestly, I would just write these as two equations to solve, and just to save you a little work.
That's true.
Let's see. We're gonna get. So
actually, yeah, we could have also not done that.
Yeah, this is a system of equations in A1 and A2.
It would have actually been easier to combine them that way. That's all good.
I mean, do it the way you feel more comfortable with. That's
all right.
And we may be hitting the Excalibur limit here, so
yep.
Keep that in mind.
I'm sorry. I should have shared this with you.
No, it's fine. Don't. It's fine. I'm watching the stream.
Hey.
But thank you.
Yeah. I was like, well, it'd be a lot faster, so you don't have to. I was thinking, like, what am I missing?
See, I called it. I called it.
Yep. I was thinking, what am I missing? Because I was thinking, like, you know, you weren't in here, so. Okay. Okay, so yeah, if we add a1 to the first equation and add a2 to the second equation, it simplifies things rather nicely. So we end up with a negative a1 and a negative a2, which are individually equal to a negative 4a2 plus 1 and a1. So a1 and a2 are opposites, which means that we can get a... let's plug it in here. So negative a1 is equal to a positive for a1 plus 1. I don't think I meant to do that. It doesn't matter, right? It's all the same. But if we plug it in the other way, though, this will allow us to add instead of subtract. If we add a 4a2, then we end up with a 3a2 is equal to 1, so a2 is going to be a third. And therefore, a1 is going to be negative.
Hold it.
Sorry.
Hold it. I'm doing something. I'm trying to catch up. I think that's a plus a2 on the top row. But below the arrow. Below the arrow. If a1 is equal to minus a2, then that means the first equation becomes... Yeah, there you go.
Right, so 5, not 3.
5, yeah.
Okay. Thank you.
No problem.
I was doing that in my head beforehand, and then somehow I just threw it out the window. Okay, so going back then, this is going to be that our x sub p is going to be a a1, a2. That's interesting, because that's not the answer I have from before. My notes must be wrong.
So the original thing was 1... I've just been sort of going along with
no, it's good.
I haven't...
It's good, yep.
Okay.
I was looking in the wrong place, that's why.
You're fine.
Hey.
I just wanted to make sure, because I'm like, well, I'm going along with you. I try not to solve these ahead of time.
Yep.
So
we can make this be a 1/5 times our vector, negative 1, 1. And this is going to be e to the, we said this is a negative, e to the negative 2t. Just trying to finish too many sentences at once. Okay. Plus, we're going to do the same thing. We need a constant multiplied by our, simplified b vector with e to the t for b. So same deal here. This is going to be 1b1 and 1b2 equal to, respectively, a negative b1 minus 4b2 and a b1 minus b2 minus 2. Same deal. Add b1 and b2 respectively.
Yep.
Gonna get a 2 B1 and a 2 B2. Alright, negative 4 B2. And here we're left with a B1 minus 2. So in the first case, divide 2 off from each of the pieces. Alright, B1 is going to be negative 2B2. So we can flip the sign on this.
Yep.
Negative 2B2 is going to be a negative parentheses B1 minus B1 minus 2, which is going to be equal to B1. So negative B1 plus 2. Add B1 to both sides, we get 2 is equal to 2B1, and so therefore B1 is equal to 1. Alright, am I missing anything this time?
And then B2 is going to be negative
Opposite and
1/2.
twice as much.
Yeah. Half as much?
Half as much. A. So, yeah.
I'll be honest, that happens to me a lot myself, so don't.
Yeah.
Struggle is real.
It's great when I do it with my developmental students, though.
And so now we have an eigenvector, basically, or a C1 vector. I shouldn't say eigenvector. This is a C1 vector and C2 vector for this.
Yep. So I'm going to take out a half here and then double the constants on the inside, so we get B1 is going to be 2.
Just in that.
And B2 is going to be negative 1. Yeah. Alrighty. And realistically, right, we actually could have grabbed that from the relationship at least, our eigenvector, if you will, which is not an eigenvector, but the vector. Would have been from the relationship itself would have been from this line up here where we got 1b1 is equal to negative 2b2. These are in the same relationship to each other. It's just that our constant 1/2 out front needed to be pinned down. Okay. So now we have our null space solution.
And what was our original matrix?
Very good question.
I just want to make sure that we're on the. There's a lot that just happened.
Yeah. There we go.
I just wanted to make sure we have the right stuff here. Okay.
So again, we have our null space solution, which was C1. Let's just copy it. Copy it somewhere else. Hang on, where is it? Oh, just up top. Yep.
Copy paste is a great invention.
Oh yeah. With all the uses of imaginary numbers for rotating in any way, shape, or form. Not that I can necessarily rotate here, but nonetheless. Alright, so we get our null space solution, we get our particular solution, and now our total solution, if we just want to call it x vector as a whole, is going to be all of that stuff summed up. So we're going to say we got our, nope, don't do that. It's going to be our x vector. It's going to be equal to c1 e to the negative t. Negative 2 sin t 2t. I already started, so you know. Cosine 2t plus c2 e to the negative t. 2 cosine 2t sine 2t, chicken scratch. Okay, plus, and change color just to highlight that. 1/5 times negative 1 e to the negative 2t